Guys, the last thing I want to talk about in this nuclear chapter is the idea of radiation exposure. By the end of this video, we should be able to list the forms of radiation that are commonly encountered, what things we're going to be encountering that's going to cause issues just on an everyday basis, and then describe what happens to cells upon radiation exposure and recall the different units of radiation dose. So radiation is all around us in the environment. There are a lot of naturally occurring radiation sources. For instance, bananas. Bananas have a form of potassium in them that is radioactive. So we are constantly exposing ourselves to potassium, radioactive potassium when we eat bananas. And a lot of different fruits and vegetables are going to have some radiation about them. I was actually reading something that said that the reason that fruits and vegetables are so healthy for us is because they give us low doses of radiation over a long period of time, which increases our resistance to it, I guess. I don't know. Just some crazy thing I read. Anyways, so we are constantly exposed to radiation. All sorts of radiation. Ionizing radiation is going to be the most harmful. And it is far more harmful than non-ionizing radiation. So our ionizing radiation is going to include stuff like X-rays and gamma rays, while our non-ionizing radiation is stuff like radio waves and light waves. And the reason that ionizing radiation is so harmful to us is because water, which makes up about 70% of our living tissue, is going to be ionized by ionizing radiation, which is an issue. So ionizing radiation ionizes water. And we're like 70% water. So what happens is we form hydroxide radicals. So the water that's ionized will then react with another water molecule and produce hydronium ions and hydroxide radicals. And this causes cell damage. So this will then go and interact with DNA and all sorts of horrible things. So what happens is we damage our cells. These hydroxide radicals, if you ever heard anybody talking about detoxifying, getting rid of all the radicals, this is technically what they're talking about, is that getting those radicals out of your body in order to make sure you stop damaging your cells, which is the cause of things like aging. The skin aging is caused by hydroxide radicals. So radicals in the body are very, very harmful. And of course, the damage to the cell depends on the type of radioactivity and the length of exposure, and then whether or not the exposure is inside the body or outside the body. So there are lots of factors when considering how dangerous radiation is to the body. So outside of the body, so if we are exposed and radiation hits our skin, gamma rays are going to be the most dangerous because they have the greatest penetration depth. So they can penetrate all the way through our body. Which allows it to ionize a bunch of water, which allows it to damage a bunch of cells. However, if, I don't know, for instance, you open your mouth, the most damaging is going to be, once it gets into your body, alpha radiation. And that's because they are the most ionizing. They are the largest at a mass number of 4, and they have a +2 charge, so they are very ionizing. They're a very ionizing form of radiation. The nice thing is that they're stopped by skin, but if you're opening up your mouth, and allowing that to go into your organs, then it's going to be very, very dangerous for you. Okay, so we are exposed to radiation, ionizing radiation all the time. So the question becomes, what amount is safe? So setting standards is going to be difficult because it depends on what type of radiation and how long the radiation occurs for, what type of long-term exposure you're experiencing. So is it a large dose at one time? Is it low levels over a long period of time? So again, there's a lot of factors as to whether how dangerous the exposure levels are. So the exposure levels, dangerous factor, I guess we could say, depend on a lot of variables. Sometimes people are exposed to low levels of radiation, but for a long term. And that can cause a lot of health issues. And of course, large doses over a short period can cause radiation poisoning, which is also very dangerous. And no matter what, there's going to be some damage to the growth regulation mechanism of the cells, and that damage to the growth regulation to the cells can result in cancer. So damage to the growth regulation mechanism of cells can result in cancer. So if a cell is allowed to just exponentially grow, that is a cancerous cell. If it's just going to keep growing and multiplying, it can be very cancerous and very dangerous to the body. Here's just a table with a couple of different natural radionuclides that we can be exposed to. For instance, potassium-40, the one found in bananas that causes low levels of radiation to be found in the body. And there's going to be low levels of radiation in everybody's body no matter what, because there are many things that we are exposed to that is going to expose us to radiation. Okay, so we usually think about two units when we think of exposure to radiation. The gray, which is GY, and it is the absorption of 1 joule of energy per kilogram of tissue. Okay, so that's our first radiation dose unit. Next one is the RAD, which is radiation absorbed dose, which is going to be the absorption of 0.01 joules of energy per 1 kilogram of tissue. So 100 rad is equal to 1 gray. And then, of course, we take into account the idea of the biological harm, because not all forms of radiation will harm tissues equally. So we have a relative biological effectiveness. which takes into account harm to body tissues. And this is RBE. And it's used to show how much biological effect there is. So these up here are our doses. This is not really a dose so much as just what's going on in the tissue itself. And then we could talk about what's called the effective dose. Which is going to be the REM, R-E-M. And this is going to be an SI unit of the sievert, where 1 sievert is equal to 100 rem. Okay, and our number of rems is equal to our number of rad times by our RBE. So if we want to look at what the actual dosage that we're getting is, taking our RADs, our radiation absorbed doses, and multiplying it by our biological effectiveness or relative biological effectiveness. Okay, so let's look at what happens with short-term exposure. So generally, long-term exposure, that's really hard to predict because it depends on the amounts and how long and really, the effect on the body itself. But we can look at short-term effects a little bit easier. We'd say that if you have 600 rem, that's going to be fatal to most humans. Okay. And then 500 rem, about half of the exposed population will be dead within 30 days. So not great. Our average exposure over a year, so this is talking about far shorter than a year, but over a year is approximately 360 millirem. So not very much. This is going to be encountering all sorts of things like consumer products. If you go get any sort of x-rays, if you have to get a radioisotope put into the body, stuff like that. And another very large cause of radiation exposure is radon. Radon comes from the soil, and it's radon, specifically radon 222. It's a decay product of uranium-238, and it is found in rock formations and soil. Naturally occurring uranium-238 is going to decay, and most of the decay products are going to remain in the soil. The issue with radon-222 is that it's a gas. So most uranium-238 products remain in the soil. Soil, no issue to us. But radon-222 is a gas, so we can breathe it in. When it's breathed in, it produces alpha particles. And alpha particles are very dangerous for the body. And they have a high relative biological effect. The estimate right now is 10% of all lung cancer deaths in the US are tied radon 222. So it can be fairly harmful. Over here on the left, we can see the average predicted indoor radon levels. And zone 1 is going to have the most prevalent amounts of radon. And a lot of times, if you look, they're going to be in more mountainous areas that you see a lot of radon, because that's where you're going to have more uranium. Okay, well, that is everything for our nuclear chapter. I will talk to you guys in the next video.